Today this is our lecture 4, so we will start with another topic. Let me share the screen. Are you able to view my screen? Everyone?
Yes,
Are
ma'am.
you able to view my screen? Okay. So let us study about three-way handshake. Three-way handshake is a type of protocol which we will see. Does anyone have any idea about three-way protocol or three-way handshake protocol? What is three-way handshake protocol? What does it mean? Any idea related to three-way handshake protocol? Has anybody heard of three-way handshake protocol? I said, everyone try to mute themselves. There's a voice coming from someone else. So try to mute yourself. Today we will learn about three-way handshake protocol. Three-way handshake is a process. Yes, someone want to say something? No. So three-way handshake.
ম্যাম সার্ভার আর ক্লায়েন্টের মধ্যে কানেকশন ক্রিয়েট করে।
সার্ভার আর ক্লায়েন্টের মধ্যে কানেকশন ক্রিয়েট করে। গুড। আর কেউ কিছু বলবে? এনিথিং মোর? Someone, any more answers from anyone? No. So TCP, three-way handshake, is a process which is used in a TCP/IP network to make a connection between server and client. It is a three-step process that requires both the client and server to exchange synchronization and acknowledgement packets before the real data communication process starts. So there is a process. There's a process of acknowledgement. Please don't talk. Yes, please don't talk. So it is a three-step process that requires both client and server to exchange synchronization and acknowledgement plan. Why it is necessary to share synchronization? It is necessary to synchronize the chatting. Ratri Ganguly, mute yourself. Noise is coming from your side, Ratri. Ratri, mute yourself. Noise is coming from your end. Okay. So why synchronization is required? Synchronization is required so that there is a speed mismatch. Sometimes what happens that there is a speed mismatch between sender and receiver. So to remove the speed mismatch between sender and receiver, a synchronization is required. If there is no synchronization, then what will happen that the receiver may be slow or the receiver may be fast, slow receiver, fast sender, or fast sender, slow receiver. These are the different types of problems. So synchronization is required. Now let me share my screen. This is lecture 4, three-way handshake and TCP/IP flags. What is three-way handshake? TCP uses a three-way handshake to establish a reliable connection. The connection is full duplex and both sides synchronize and acknowledge each other. The exchange of these four flags is performed in 3 steps: synchronization, and then synchronization and acknowledge, and then acknowledge. These are the main 3 steps of three-way handshake process. This could also be seen as a way of how TCP connection is established. This is a way of how TCP connection is established. This is the process of establishing the TCP connection. TCP, as you all know, it stands for Transmission Control Protocol, which indicates that it does something to control the transmission of the data in a reliable way. The process of communication between devices over the internet happens according to current TCP/IP suite model. The application layer is at the top of TCP/IP model, from where network referenced application talking, or from where Ratri, someone call Ratri and ask him to mute herself. Bijish, you ask Ratri to mute herself. There's a disturbance coming
Okay,
from.
ma'am.
Yes, please ask
Okay,
her.
ma'am. Okay, ma'am. Okay, ma'am. There is Ratri. Ma'am, Ratri is muted only.
She has now muted herself. There was a voice coming from her side. Okay, so it is the process of communication between devices over the internet and happens according to the TCP/IP suite model. TCP/IP is a suite model and it happens as per the model. So the application layer is at the top of TCP/IP model, from where network referenced applications like web browser on the client side establish connection between server. So from the application layer, the information is transferred to the transport layer. From where the information is transferred? The information is transferred to the transport layer. So from the we can say that the two important protocol of this layer are TCP and UDP, as you all know about that. And TCP provides reliable communication with something which is called positive acknowledgement with retransmission. The protocol data unit, or PDU, of the transport layer is called segment. Now a device which uses positive acknowledgement and retransmission resend the data until it is received with an acknowledgement. So the data resending is being, it is necessary to resend data so that there is a two-way transmission between the sender and the receiver. So there is a two-way transmission. This is the process. Host A initiates the connection by sending the encryption for security. Yes, it provides encryption for security. There are different layers in TCP/IP protocol, and each and every layer performs different types of functions. Okay, so it sends a segment with synchronization which informs server that the client is which informs the server that the client is likely to start communication and with what sequence number it starts segment with. That means the sequence number is important. Which sequence number, from which sequence number it is starting the information. Step 2 is synchronization plus acknowledgement. Server responds to the client request with synchronization and acknowledgement signal bit set. Acknowledgement signifies the response of segment it received, and synchronization signifies with the sequence number it is likely to start the segment with. It means that if there is an error at the receiver side, suppose the sender is sending data, and if there is an error at the receiver side, then what the sender will do, sender will resend the data, but not from the starting. It will resend the data only after the point the error is being encountered. It means suppose there are 20 packets that need to be that needs to be sent from sender side to receiver side, and after 10 packets an error is encountered, then the retransmission will be done only after 10th packet. It is not that each and all data is retransferred. The retransmission will be done after 10th packet. So that is the process of three-way handshake, or that is the purpose of three-way handshake. Okay. Now next, go to the next slide. This is the diagrammatic representation, host and server, synchronization, synchronization plus ACK, and acknowledgement. So host sends synchronization symbols to the server, and server sends synchronization and acknowledgement to host, and host is sending acknowledgement to server. Again, come to the different diagram, synchronization plus acknowledgement and acknowledgement. This is one of the more diagram. Now we come to TCP flags. One part was three-way handshake and another part is TCP flag. Does anyone have any idea about TCP flag? What is TCP flag? For what it is being used? Does anyone have any idea? TCP flags? Anyone? TCP flags? You can unmute yourself and speak. First of all, it is necessary to understand that in a communication, why TCP flag is required. What is the need of TCP flag? That is necessary. In any TCP connection, flags are used to indicate a particular state of connection or to provide some additional useful informations like troubleshooting purposes or to handle a control of particular connection. Most commonly used Sorry, I was muted. There was some problem at my end. So let us start with TCP flags. TCP flags are used within TCP packet transfers to indicate a particular connection state or provide additional information. Therefore, they can be used for troubleshooting purposes or to control how a particular connection is handled. So this is the concept of TCP flag. There are few TCP flags that are more commonly used than others. What are the flags? These are the list of flags: synchronization, acknowledgement, finished, URG, PSH, FST, and ECE. I think these flags are new for you all. This is the purpose of synchronization flag. All of you just go through what is written. The synchronization flag is used as a first step in establishing a three-way handshake between two hosts. Only the first packet from both the sender and receiver should have this flag set. The diagram illustrates the handshake process as which the previous diagram which you have seen earlier. This is the diagram. It shows the process. Now let's go back to different flags. Synchronization we have seen. Acknowledgement. Acknowledgement flag is used to acknowledge the successful receipt of a packet. As we can see from the diagram which was given there, the receiver sends an acknowledgement as well as a synchronization in the second step of three-way handshake process to tell the sender that it receives its initial packet. As soon as the initial packet is received, it sends the acknowledgement. Let's look at another flags. Finish flag. Finish flags means there is no more data from the sender. This flag is sent after the transmission is over or it is used in the last packet sent from the sender. URG. The urgent flag is used to notify the receiver to process the urgent packets before processing all other packets. The receiver will be notified when all known urgent data has been received. So this is the working of urgent flag. It is which flag? Suppose there is a when the data transmission is being done, there is some data which are urgent data. So URG flag is used to notify the receiver that these processes are urgent. PSH. The push flag is similar to URG flag and tells the receiver to process these packets as they are received instead of buffering them. This is the function of push flag. That when the processor packets are received at the receiving end, then PSH flag is set. RST, the reset flag gets sent from the receiver to the sender when a packet is sent to a particular host that was not expecting it. If anyone has any confusion, they can ask. RST flag, reset flag. Then ECE flag. ECE, this flag is responsible for indicating if the TCP peer is ECN capable. ECN allows end-to-end notification of network congestion without dropping packets. CWR, the congestion window reduce flag, is used by sending host to indicate it received a packet with the ECE flag set. This is the congestion window reduce flag. If there is a congestion from sending the data from sender side to receiver end, then congestion window reduce flag is used. Now NS is experimental. The noun sum flag is still an experiment. It is used to protect against any accidental or malicious concealment of packets from the sender. Now suppose there is certain malicious concealment, means there is certain kind of attack, or during the process of sending the data from one end to another end there is an error, then experimental data is sent. So let's go to next. This is TCP IP head or TCP header format. Source port, destination port, sequence number, acknowledgement number. These are different TCP header formats. Checksum and urgent pointer. These are TCP header formats. Can anybody tell me about this? What are the different fields of TCP header format? What are the different fields of TCP header formats? Source port, destination ports. What are those formats? Source port is about sender. Destination port is the destination address, and it 32-bit data is sent from one end to another end. This is all about today, but let me explain the TCP header format. There are different fields of TCP header formats which are discussed here. Let us look at one of the fields one by one. First is source port address. What is source port address? It is a 16-bit field that holds the port address of the application that is sending the data segment. Destination port address. Destination port address is again a 16-bit field that holds the port address of the application in the host that is receiving the data segment. Sequence number, 32-bit field that holds the sequence number. That is the byte number of the first byte that is sent in that particular segment. It is used to reassemble the message at the receiving end if the segments are received out of order. Suppose a message is broken into different segments and at the receiving end, the messages are received out of order. What does out of order means? Then the second message is received first and the first message is received after that. So the order of the message is different than the original order, which should not happen. So sequence number, due to the information given in sequence number, the message is rearranged sequentially. Acknowledgement number, 32-bit fields that holds the acknowledgement number. That is the byte number that the receiver expects to receive next. This is the byte number. Header length, H length. This is a 4-bit field that indicates the length of the TCP header. What is the length of the TCP header? That is being indicated by TCP header, this field. And the maximum length is 60 bytes. Why 60 bytes? Because this field can hold 5 and 5 into 4, 20 bytes. So minimum is 20 byte and maximum is 16 bytes. Now in the diagram, there were different control flags. What are control flags? These are 6 1-bit control that controls connection, establishment, connection termination, connection abortion, flow control, mode of transfers, etc. In this control flag, there were other fields also like URG, ACK, PSH, RST, SYN, FIN. What were those fields? URG stands for urgent pointer field. ACK is acknowledgement number. PSH, request for push. RST, reset the connection. SYN, synchronize sequence number. And FIN, terminate the connection. These are the different fields. The window size, the field tells the window size of the sending TCP in bytes. Checksum, this field holds the checksum for error control. It is mandatory in TCP. Urgent pointer, this field is used to point to data that is urgently required, that needs to reach the receiving process. That means the receiver process must reach it. TCP, it must be kept in mind that TCP is a connection-oriented protocol. I think this is all from my side. I will request you all to continue the assignment and questions in a separate worksheet, just like I have explained earlier. And if there is a confusion, then you can ask. So I think from today's class, we have learned about the three-way handshake, what are different TCP flags, and how the TCP header works. What is the working of TCP header that we have seen. So I will give you a minute to ask if there is any confusion, else I will end the meeting. There is any confusion? If there is any, you can ask. So nobody has any confusion. So I am ending the meeting.